Good morning. Welcome back to Math 8. I know it's super exciting. It's the best part of your every other day. Well, hopefully it is. So today we're going to take the next step, which is called scientific notation. This is something that's super important. You're going to use this a lot when you get to science classes. So let's just think about the universe for a second. Have you ever thought of, or do you even know what the speed of light is? Well, this is the pretty much close to almost being perfect speed of light. 299,792,458 meters per second. How did they figure that out? Well, it's a whole calculation thing. I'm not into that. But anyway, that's the speed of light. What about the wavelength of red light? Well, the wavelength of red light is 0.0000007 meters. That's really small. Well, what about the wavelength of blue light? Well, that's 0.0000004 meters. These are insane numbers. It's not fun to deal with all those numbers, as they are. So let's just take the famous Einsteinian and whatever, from Einstein. Equals E equals mc squared. And basically it just says it's the correlation between the energy and the mass of something. So how much energy does something have if you can turn the mass all into energy? Well, you take that mass, you multiply it by the speed of light squared, and you get it. Well, let's just take something that weighs 1 gram, basically the size of a grape. Well, what would you do? You'd multiply 299,792,458 by itself. It's an insanely large number. Imagine wanting to do that, though. Not wanting to. Imagine doing that longhand. Miserable. Okay? It is completely insane. So there's got to be a better way. And there is a better way. And that better way is scientific notation. All right? There's a reason why it's called scientific notation because it's used in science a lot. Okay. What is it? It's basically where you write a really big number or a really small number as a power of 10. Okay, it's a multiplication problem, or it's an equation and express an expression. You wrote it as a multiplication expression as you multiply by something times a power of 10. Not so bad. Does it have to be a huge number and a really small number? No, you can use regular numbers too, but you'll see when we get there. Okay. So why? Well, like I kind of said, chemistry, physics, biology, it's used all the time in here. In biology, you'll use very, very small things. So the SARS-CoV-2 virus, the one that's causing COVID-19, this is the size of it. 0.0000008. I think I got enough zeros in there too. 0.000000014 meters. That's really small. It's about the size of a wavelength of light. It's actually smaller than that. It's kind of crazy to think about. Or when you get to chemistry, one of the huge concepts that you're going to use is something called a mole. If you don't know right now, that's fine. You'll learn in a couple of years. And in order to calculate things with moles, you need to use Avogadro's number, which is 602 3 zeros, 3 zeros, 3 0. How many zeros is that? 1, 2, 3, 4, 5, 6, 7 times 3. So 21 zeros after that. I don't even know what that number is. Okay, doesn't matter. What is Avogadro's number? It's the number of molecules in a mole of whatever it happens to be. Okay, so I think you covered this last year when you're dealing with the periodic table and you were looking at the atomic weight of different the atomic weight of different elements. And what happens is the atomic weight is the number, it's this number, Avogadro's number, that many molecules, that's how much it weighs. So whatever it happens to have been. So again, trying to multiply with that is just utterly insane. So we don't ever do that, okay? So what we do is we create something, well, not create it, we turn them into something called scientific notation, right? And what it allows you to do is allows you to multiply these numbers significantly easier. So all you do is plop a couple numbers into a calculator, boom, 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 you're done. It makes a nearly impossible task very, very manageable. Now today we are not going to be doing any of the calculations. We are only going to be writing the numbers in scientific notation. That's it. Okay. Not sure if we're going to get to the calculations of it yet because we only have so many days left after this. So I will look at our schedule. My hunch says no, but if we have any time at the end of the year, we might do a little bit of that. But there are a couple other things I have to get to you. I have to teach you guys first. Okay, so let's try it. Any WWE fans out there? Yes, yes, yes. Okay, let's look at the first one. It's a pretty simple number, 8,600. So to write that as scientific notation, we need to write it as a number times a power of 10. So when we're writing in scientific notation, we always have one number to the left of the decimal. So we only go to the units place or the ones place. Then we have a decimal point, and then we have numbers to the right. We don't always have to have numbers to the right, but if we do, okay, you can have one, you can have as many as you need to. We tend not to, we don't write zeros at the end. We only write a zero if it's in between. You'll see that in a minute. Okay, so what do I multiply 8.6 by to get to 1,000, to get to 8,600? Well, I'd multiply it by 1,000. Not very complicated. So what is 1,000 written as? A power of 10. Again, you did this in 5th grade. 10 to the third. Okay, so this written as scientific notation, so we need to have the 8 first, decimal point, then the 6. What do I multiply that by to get it to equal that? Well, it's 1,000, 10 to the third. Now, there's a much easier way to do that. That's what it equals. So how do we figure this out? Basically, right now, the decimal point is right here. And what we have to do is we have to see how many times do we shift it in order to get it to right after this number. Okay, so let's see. If it's right here, it would go 1, 2, 3. Boom, right there. What is my exponent? Oh my gosh, 10 to the third. Now, why does that happen? You did this in 5th grade, right? Every time you multiply by a power of 10, it shifts the number left. And if you multiply by a tenth or 100th, it shifts it the other way. It shifts it to the right. And now we learned the other day that that would be a negative exponent, right? 10 to the negative 1 is a tenth. 10 to the negative 2 is 1/100th. Same thing you did, in 5th grade, except it looked slightly different in 6th grade. Okay, so let's come up with the next one. Let me move myself over here because it's going to be over here. Okay, 0.0024. So what happens is I need to get my decimal point right here. How do I do that? Well, my decimal point's here. I need to move it here. So remember, each time I'm moving it this way, I'm multiplying it by a power of 10, but it's a tenth. So the first time if I move it here, if I multiply it by a tenth, it goes there. If I multiply it by 100th, it goes there. If I multiply it by 1,000th, it goes there. So to really get this number, I would do 2.4 times 10 to the 1 times 1,000th. What is 1,000th written as a exponent? 10 to the negative third. Now the trick of it is, okay, how many times do you move the decimal point? Well, I moved it 3 spots. 1, 2, 3. Okay. Now, why is it negative when I go this way? The main reason is, if you think about it, what am I going to multiply this by to get something smaller? Okay, it has to be between 0 and 1. That's why it's going to have a negative exponent in there, right? Because a negative exponent means the 10 is in the denominator. All right, let's try some more. Woof, 173 million. All right. So what we need to do is make this as 1.73, right? Because I need to have my decimal point here. I'm only allowed to have one digit to the left of the decimal point. So my decimal point needs to go there. Right now it's here. So let's see how many times do we shift? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it gets written as 1.73 times 10 to the 8th. Now this is just what a little picture of if you want to write it down and you can actually count the times that you shift your decimal point. That's just one of the ways you can do it. All right, 0.000032. Well, obviously I need to have this as 3.2. So what would I multiply this by? 3.2 by to get to this number? Oh, let's see. How many times am I going to shift my decimal point? 1, 2, 3, 4, 5, 6. So I need to multiply 3.2 times a millionth. So it's 3.2 times 10. Now it's negative, okay, because it's smaller than 1 whole. So to the negative 6, because I moved it 6 spots. Okay. And what this really means is if I take 3.2 and I multiply it by 1 over, 1 million? No. Yes, 1 over a million. So 1/1,000,000th, it would give me this number. Kind of crazy to think about. Okay. That's just a pretty little picture of what it looks like. So that was going from standard form to scientific notation. Now we can also go from scientific notation to standard form. Not overly complicated. So basically what happens is if the exponent is negative, the decimal point moves to the left. Because if the decimal point moves to the left, the number gets smaller. Again, you did this in 5th grade. If the exponent is positive, you're moving the decimal point to the right, because really what you're doing is you're shifting the number in the place value. You're making it a larger number by doing that. Okay? So the first one is 3.22 times 10 to the negative 4th. Okay, so it's a negative exponent. So if it's a negative exponent, you remember what it looked like over here. Okay, negative exponent looks like this. It's a 0 point and then a whole bunch of zeros until you get to your number, right? So what this is basically doing is I'm going to start at here and I'm going to shift this to the left, the decimal point to the left, okay? So the first thing you guys do is I shift it 1 spot. Well, now I need to shift it again. Well, I don't have anything there. Well, you do. You have a whole bunch of zeros. You have as many zeros as you need. Remember you did this when you're learning long division and you could annex a 0, right? You had the decimal point at the end and you could put in as many zeros as you needed to because it's there. Remember, you have infinite number of zeros on either side that you can use. So I need to shift it 4 times. So I shifted it once to there. Okay. Now here's twice. 3 times. I'm almost there. I need to shift it 4 full times. So right here. So the decimal point was originally here. 1, 2, 3, and 4. So it's always a good thing to do is check it when you get to the end just to make sure that you did it right. So with the decimal point, you start where the decimal point was. And now you count. How many times? 4 times. 1, 2, 3, 4. Okay. So there's your final answer, 0.00032. Just to show you what it would look like again, you start with the decimal point here, you shifted and you kept shifting until you had all four places were moved. Okay, so this one is a positive exponent, which means that we're going to be shifting the decimal to the right, and that's just going to make the number bigger. That's all it's going to do. So I first start with 7.9. Okay, and I'm going to move my decimal 5 spots to the right. So I'm starting here. If I move it over once, okay, I get 79. Twice, 790. 3 times, 7,900. 4 times, and 5 times. So you notice I just move the decimal place over once, so there's my 1, and then I just start adding zeros until I get to 5. So 1, 2, 3, 4, 5. So there's my number. There's my answer. So what does it look like? Well, you start here, and then you just keep shuffling over till you've moved over 5 spots from where the decimal point was until the end. All right. That is it for the day. So good luck on your assignment. Please reach out if you need any assistance. I will, well, you will see me soon next class. All right, bye.